Good morning, children. This session we are going to discuss about the mixtures. I hope in your lower classes you might have heard about this word mixture. In chemistry, a mixture is a material made of two or more different substances. Substances which form a mixture are called components. There are two types of mixtures. One is the homogeneous mixture and another one is the heterogeneous mixture. What is the difference between homogeneous mixture and heterogeneous mixture? In a homogeneous mixture, all the components mix uniformly. That is, the composition is uniform throughout the mixture. Okay. So in the homogeneous solution, we cannot see the components by our naked eye or with the help of a microscope. Why? Because all the components appear as a single phase. Okay. For example of homogeneous mixture are salt dissolved in water, sugar dissolved in water, methyl alcohol dissolved in water, and then iodine dissolved in carbon tetrachloride. These are some of the examples of homogeneous mixture. Okay. So look at this mixture. This is an example of homogeneous mixture. Okay. Here two components are added. One is water and another one is salt. That is salt dissolved in water. So this is an example of homogeneous mixture. If you add salt in the water, and also you mix it well, immediately you will see the only one phase. Immediately you will see the components, both the water as well as salt, it gets dissolved completely and it appears as a single phase. Okay. So through our naked eye we cannot see the salt separately and water separately. Both the components get mixed here. So here salt dissolved in water, also sugar dissolved in water are some of the examples of homogeneous solution. Okay. So this solution is an example of homogeneous solution. It is salt dissolved in water. Okay. If you add salt in water and mix it well, then you will see the single phase only. So this is an example of homogeneous solution. Got it, children? So homogeneous solution means what? In a homogeneous solution, all the components mixed uniformly. What are the components we added here? Salt as well as water. So both the components mixed uniformly. Here the composition is uniform throughout the mixture. Not only separate place. Throughout the mixture, the components mixed uniformly. This is an example of homogeneous mixture. Got it? Right. Next we can move to the heterogeneous mixture. In a heterogeneous mixture, the components are not mixed uniformly. Okay. Here the composition is not uniform. Okay. For example, if you add sand in water, okay, if you add sand in water, you will see sand as a separate phase and as well as water as a separate phase. Here, the components will not get dissolved. You cannot see the components through your naked eye as well as you can see. Okay, in homogeneous mixture, you cannot see the components because it gets uniformly mixed. But in heterogeneous mixture, you can see the components with your naked eye, also with the help of a microscope, because the components it will not mixed. Okay, it will you will see the components as a separate phase. For example, if you take this here, this is the water and I added some sand into it. Okay, if I mix this. Even though if I mix it well, it will not get mixed. Okay. See what happens? All the water it appears as a separate phase and all the sand particles it settles at the bottom. So you can see the components, that is water as well as sand. Through our naked eye or with the help of microscope also you can clearly see. This is called the heterogeneous mixture. Okay. So what is meant by heterogeneous mixture? In a heterogeneous mixture, the components are mixed uniformly. Water as well as sand, even though if you mix it well for very long time, it will not get mixed. The sand particles settle at the bottom and all the water particles it will come at the top of the beaker. Okay. So this is an example of heterogeneous mixture. Now tell me what's the difference between homogeneous mixture and heterogeneous mixture. First of all, what do you mean by mixture? In chemistry, a mixture is a material made of two or more different substances. This is called mixture. And there are two types of mixture. One is a homogeneous and another one is a heterogeneous mixture. Homogeneous mixture means all the components mixed uniformly. Okay, you cannot see the components through your naked eye. And if you take the heterogeneous mixture, here all the components, okay, it will not get mixed, right? You will see the separate phases only. Through your naked eye, you can see the components. Okay, that's the difference between homogeneous mixture and heterogeneous mixture. Got it, children? It's a very important 2-mark question, right? So next we can move to the preliminary techniques. Okay, for separating the mixtures, some preliminary techniques can be followed to separate the mixtures. What are the techniques? First one is the filtration, second one is sublimation, third one is distillation, and the last one is the magnetic separation method. First, let me see the filtration method. Okay. Here, filtration method, it is a process in which the separation of insoluble solid. Okay, filtration method, it is a process of separating the insoluble solid. Okay, insoluble solid from a liquid. This is the filtration process. So, when you add some sand in water and mix it well, and with the help of a funnel, if you add that sand mixture, all the sand particles will stay behind the filter paper, and the water passes through the liquid passes through into the conical flask or otherwise beaker. Okay. So, what is meant by filtration? Filtration means it is the process of separating the insoluble solid from a liquid. When a mixture of sand and water is filtered, all the sand particles stay behind in the filter paper and the water passes through the filter paper. Okay. So, look at this one. See, this is the funnel. Okay, here if you see this funnel, all the sand particles it stay behind the filter paper. See, the sand particles stay behind the filter paper and the water it passes through the filter paper. Okay, and the remaining water it passes through the filter paper. So this some sand particles stay behind in the filter paper. No, this is called the residue. Okay, this is called the residue. It is nothing but the waste product, and this is called the filtrate. Okay, so what is meant by filtration? Filtration process, it is the process of separating the insoluble solid from a liquid. Okay, so these are insoluble solid. Look at the board now. Here, so this is take one beaker and add some water and then some sand. Okay, add water and then sand. This is nothing but a mixture of sand and water. Okay, this is the mixture of sand and water. So next one, look at this one. So this is the beaker and this is the funnel. So this is the funnel. Okay. here in this funnel we have to keep the filter paper. Look at this funnel here. All the sand particles stay behind the filter paper. Okay, all the sand particles stay behind the filter paper and the water passes through the filter paper. If you keep the funnel like this, the sand particles will stay behind the filter paper and the water passes through the filter paper. Here some sand particles stay behind. No. So this is nothing but the residue. Okay. These are called residue. It is nothing but the waste product and this liquid is nothing. It is called the filtrate. Got it, children? Right. So look at the board now. Here in this first beaker, a mixture of sand and water is given. Okay. Sand as well as water mixture is given, and in the second picture, see here one beaker is there and the funnel is inserted here. In this funnel, what is this? It is nothing but a filter paper. So this paper is called the filter paper. For filtration purpose, we are using this filter paper. Okay. So this is the filter paper and all the sand particles here. What are the things we added? We added water as well as sand, isn't it? So in this filter paper, all the sand particles will stay behind the filter paper and the water passes through this filter paper. Okay, water passes through this funnel, right? And come to the third picture. Here, all the residue, that is waste materials are settled at the filter paper. So these are the waste materials settled in the filter paper. These are the waste material, that is nothing but residue. Residue means unwanted things, waste materials. Okay. So these are the filtrate. This is the filtrate. Understood, children? What is meant by filtration? Filtration, it is a process of separating the insoluble solid from a liquid. This is the main point. Okay. So what is filtration? Filtration is a process of separating the insoluble solid. These are insoluble solid from a liquid by using filter paper and funnels. Got it, children? Right. Shall we move to the second one? Good. So next one we can move to the sublimation. Sublimation, it is a process of converting solid state into gaseous state, okay, without changing into liquid state. What is meant by sublimation? It's also very important 2-mark question. Sublimation is the process of converting the solid phase into gaseous phase without changing into liquid state, okay. For example, snow and ice can sublime in the winter months without melting. Okay. And dry ice is otherwise called as solid carbon dioxide. This solid carbon dioxide can sublime. Okay. And through this sublimation process, naphthalene can be separated from common salt. Okay. So define sublimation means what's the answer? Sublimation is the process of converting solid phase into gaseous phase without changing into liquid. Got it, children? Understood? Shall we move to the next one? Good. So next we can move to the distillation process. Okay. So this is look at this diagram. Distillation process. It is the process of involving the conversion of, okay, it is the process of involving the conversion of liquid into vapor state, that is condensed back into liquid again. Okay, what is meant by distillation process? Distillation process, it is a process involving the conversion of liquid, okay, into gaseous state and then condensed back into liquid again. So this is the distillation process. Okay. So look at this diagram. So this is the distillation flask. In this distillation flask, salt and water is mixed. So this is the Bunsen burner. This burner is used for heating purpose. Okay. This is the stand. This is the stand. fixed with this distillation flask, and this is the clamp. Okay, this is the clamp. Here one thermometer is inserted to check the temperature of that particular time we have to check the temperature. Okay, that's what thermometer is inserted here, right? This is the distillation flask, and this is the condenser, Liebig condenser. Through this Liebig condenser only, this liquid solution condensed into water again. Okay, changes into vapor and then condensed back into liquid again. So this is mainly used for in this condenser we are using now. This condenser, by using we are using the Bunsen burner. So at a particular time, if the temperature it goes very high, that's what cooling water is used. It is mainly used for cooling purpose. Okay, so this is a cooling water, and through this condenser, this condensed water is received in this receiving flask or conical flask. Okay, salt and water is mixed now. So by using this condenser, this salt water is condensed and changes into liquid. This condensed water is received in this receiving flask or conical flask. Okay, here we get the pure distilled water. Okay, so distillation method is also, it will come under the 2 mark question. Define distillation method or define distillation process. Okay, so that concept you should remember. So next one is the magnetic separation. Magnetic separation method, it is a method of separating the components of a mixture by using magnets to attract the magnetic material. Okay, so magnetic separation is the process of separating the components of a mixture. Okay, separating the components of mixture by using what? Magnets to attract the magnetic particles. Okay, for example, removing iron fillings from silica. This example we can say for magnetic separation. Okay, look at this diagram. So this setup is used. Okay, this setup is used for this magnetic separation process. Here, this is nothing but the conveyor belt. Okay, this setup is used in the conveyor belt, and also 2 wheels are attached here. Okay, 2 wheels are attached here. This is the conveyor belt. This one of this wheel is magnetic in nature. 2 wheels are there now. So this wheel is magnetic in nature. Okay, here this is a powdered ore. If you put the powdered ore through this, all the particles, all the ore particles, it will move like this. Okay, since this wheel is magnetic. Okay, so if you add the powdered ore, so this through this, that ore is just coming like this. Okay, because this is a wheel, so it will rotate in this manner. Okay, since this wheel is magnetic in nature, so all the magnetic ore means what? It contains all the magnetic as well as non-magnetic particles. Here, this wheel is magnetic in nature. So this wheel receives all the magnetic materials and it collects as a separate heap like this. And all the non-magnetic materials which is coming from this wheel, it is separated. It is collected separately like this. Okay, so these are non-magnetic materials and these are magnetic materials. Okay, once again I will tell you, this setup is mainly used for magnetic separation. This is the conveyor belt. This is the conveyor belt and it is attached with 2 wheels. Okay, from these 2 wheels, one of this wheel is magnetic in nature. If you pour the ore materials, it moves continuously. This conveyor belt it moves continuously like this. Okay, since this wheel is magnetic in nature, it collects all the magnetic materials into a separate place, and in the same wheel it collects non-magnetic materials into the separate place. Okay. So in this manner we can separate the iron fillings. This method of separation is called the magnetic separation method. Got it, children? Right? Good. So this is the conveyor belt. Through this way we have to pour the powdered ore. This is the moving well. So continuously it will move and two wheels are there. This is the stand to fix this wheel. This wheel is magnetic. So it collects the magnetic particles separately and non-magnetic particles separately. This method is mainly used to separate the iron fillings. Got it, children? Do you know the filtration method, sublimation process, distillation process and magnetic separation process? Good. Chemistry is the study of matter, which is anything which occupies space and has weight. Chemistry is the branch of science which deals with the natural universe. Okay. So in a scientific method, a guess or hypothesis is tested through observation or experimentation. Okay. Now we are going to see about the measurements in chemistry. Not only physics, even in chemistry also we use some measurements. Okay. So what are they? Let me see now. First, let me move to the measurement in chemistry. In that two units we are going to see. One is the fundamental units and another one is the derived units. What is the difference between fundamental units and derived units? What are the examples we can give for fundamental units as well as derived units? Let me see now. So look at the board. Fundamental units means the standard unit. Fundamental unit is nothing but a standard unit which are used to measure the fundamental quantities. Okay. So fundamental units are the standard units which are used to measure the fundamental quantities are called the fundamental units. Okay. It's a very important definition. Once again I will tell you. Fundamental units. So the standard units which are used to measure the fundamental quantities are called fundamental units. For example, length, breadth, height, these are some of the fundamental units. Okay. So the standard units which are used to measure the fundamental quantities are called fundamental units. Example, length, breadth and height. Then what is meant by derived units? The units which are used to measure the derived physical quantities. Okay. The units which are used to measure the derived physical quantities are called derived units. Example, area, volume. Okay. Now you know the difference between fundamental units and derived units, isn't it, children? Both are very important 2 mark questions. Okay. Now let me move to the SI units of measurement. Okay. SI means System International or International System of Units. This is also very important one. Okay. What are the SI units? First you should know the abbreviation for SI. SI means System International or International System of Units. Okay. So in this we are going to see about the 3 units in this SI unit. One is the Cgs system, second one is the FPS system and third one is the MKS system. Okay. What is C, what is G, what is S? Let me see now. Cgs system. Here in this system the unit of length is centimeter, unit of mass is gram and unit of time is second. Now you know what is CGS. C stands for centimeter, G stands for gram and S is second. So centimeter, gram, second. Okay. So CGS system means what? Full form is centimeter, gram, second. So in this system the unit of length, this centimeter is the unit of length is centimeter, unit of unit of time is second. Okay, once again I'll tell you. So Cgs system, in this system, the unit of length is centimeter, the unit of mass is gram, and the unit of time is second. You understand, children? Now Cgs system is right. Second, we can move to the FPS system. Okay, so FPS. F means food, F-O-O-T, food. P is pound, P-O-U-N-D, pound, and S is second. Food, pound, second system. Okay, so FPS system. In this system, the unit of length is foot, unit of mass is pound, and unit of time is second. Okay. So FPS is foot, pound, second system. Okay. In this system, the unit of length is foot, unit of mass is pound, and unit of time is second. Got it? Right. Next, what is MKS system? MKS means meter, kilogram, second system. Okay, MKS means meter, kilogram, second system. So in this system, okay, the unit of length is meter, unit of mass is kilogram, and unit of time is second. So you should know the fundamental units, then only you can abbreviate all these things. Okay, so what are the SI units of measurement? One is Cgs system. Cgs is centimeter, gram, second system. Second one is MKS system, meter, kilogram, second system. And the next one is FPS system, foot, pound, second system. Understood, children? Shall we move to the system of units now? Good. So next we can move to the system of units. Okay. Here, what are the things you should know? One is SI units. Okay. What are the physical quantity? What are the physical quantities given? Next one is you should know the SI units, okay, and also you should know the symbol. Okay, so in SI units you should learn about the physical quantities, its unit as well as its symbol. All these things are very important. You may get this question in a detailed answer or otherwise in 1 mark or 2 mark. Definitely, it's also very important fundamental thing. Okay, so when you go to higher classes, this is the fundamental things. By using this, you will apply many formulas like that when you go to higher classes. Okay. So first one, physical quantity in that length. Okay. So length. What is the unit of length? Its unit is meter. Okay. You should not use capital M. Use small m. Okay. So length is measured in meter. And what is the symbol of meter? The symbol of meter is small m. Here also for symbol you should not use capital M. Okay. But for some physical quantities you should use capital letters. That is, if the name, the physical quantity name will come under the scientist name, then we can use for that particular physical quantities we have to use capital letters. Okay. Otherwise, we should use only lowercase, that is small letters only. Okay. So length is measured in meter and its unit is small m. Got it? Right. So next one, mass is measured in kilogram and its unit is kg. Okay, small kg. Okay. So mass is measured in kilogram and its unit is kg. Third one, time. Time is measured in second and its unit is small s. Okay. So time is measured in second and its unit is small s. Next one is temperature. Temperature is measured in Kelvin. Kelvin is the name of the scientist. So we have to use the symbol first letter as capital K. Okay. So scientist name means we have to use capital letter for symbol. Otherwise we should use small letters. Kelvin. Temperature is measured in Kelvin. Kelvin is the name of the scientist, so we have to use capital K. Okay. So what is the unit? What is the symbol of temperature? Capital K. Next one is electric current. Electric current is measured in ampere. Okay, ampere is also name of the scientist. So we have to use the symbol capital A. Got it, children? Electric current is measured in ampere and its symbol is capital A. Next one, luminous intensity. Luminous intensity is measured in candela and its symbol is Cd. Okay, Cd, small d. Luminous intensity is measured in candela, its unit is Cd. Next one is amount of substance. Amount of substance is measured in mole and its symbol is MOL. Okay, MOL is mole and symbol is MOL only. Got it? Amount of substance is measured in mole, its symbol is MOL. Got it, children? So what are the system of units? Here we have to put the tabular column. One is for serial number, next one is physical quantity, next one is unit, and the last one is symbol. First physical quantity is length. Okay, length is measured in meter, its symbol is m. Mass is measured in kilogram, its unit is kg. Temperature is measured in Kelvin, its symbol is capital K because Kelvin is the name of the scientist. Electric current is measured in ampere. Ampere is the name of the scientist, so we have to put capital A as symbol. Next, luminous intensity is measured in candela, so its symbol is Cd. Next, amount of substance is measured in mole, its symbol is MOL. It's a very important detailed answer. Got it? Now, right. So next we can move to SI units for some common derived quantities. As I told you, derived quantities means area, volume, density, acceleration, speed, distance. These are some of the derived quantities. What is the formula for this? Let me see now. First one, that is SI units for some common derived quantities. These questions will come under one mark question, right? So area is equal to length into breadth. What is the formula of area? Area is equal to length into breadth. Okay. So m into m. M is nothing but meter. Length is measured in meter. It's also length is measured in meter. So meter into meter, that is equal to meter square or square meter. Okay. So what is the formula for area? Area is equal to length into breadth. Length is measured in meter. So the breadth is also measured in meter. So m into m is meter. So that is equal to meter square, or otherwise we can say square meter or meter square. Anything we can say, both are same only. Okay. So next one we can move to volume. Volume is equal to length into breadth into height. Okay. Length into breadth into height. This is nothing but volume. So what is the formula here? M into m. M is what? M is nothing but meter. Okay. So meter cube, or otherwise we can say cubic meter. Got it? Volume is equal to length into breadth into height. That is equal to m into m. So we can put m cube or meter cube or cubic meter. Got it? Right. So next we can move to density. Density is equal to mass by volume. That is equal to kilogram per meter cube. Okay. So density is equal to mass by volume. That is equal to kilogram per meter cube. Next one is speed. Speed is equal to distance covered into time taken. Distance covered into time taken is equal to speed. So its formula is meter per second. Okay. So this speed is equal to distance covered into time taken. That is equal to meter per second. Next one is acceleration. Acceleration is equal to change in velocity by time. That is equal to meter per square second. Okay, meter per square second. That is acceleration is equal to change in velocity by time taken. That is equal to meter per square second. These are the 5 important common derived quantities. Okay, children. So in this measurement of chemistry, you should know the main formulas. What are the formulas? What are the system international of units? FPS system means what? MKS means what? This FPS, MKS as well as CGS, always you should use capital letter like this. Here you should not use small letters. Okay. So CGS, FPS, MKS, you should know what is CGS. CGS is centimeter gram second, FPS is foot pound second, MKS is meter kilogram second. Okay. And apart from that, system of units, in that you should know about the fundamental quantities. What are the units for each and every fundamental quantities, and finally you should know about its symbol. Okay. So next step followed by common derived quantities, and the basic thing is first you should know about the fundamental units and derived units. Got it, children? Okay. So in this section, what are the things we discussed? One is about the mixture. What are the two types of mixtures? Homogeneous mixture and heterogeneous mixture. Next we saw some techniques, preliminary techniques to separate the mixture. What are the preliminary techniques we saw? One is the filtration, second one is the sublimation, third one is the distillation process, followed by magnetic separation method. Next we discussed about the measurement in chemistry, in that fundamental units, derived units, followed by SI system of units or international system of units, in that FPS system, CGS system, MKS system, and then system international of units, that is what are the physical quantities, its unit as well as symbol, followed by some common derived units. Okay, common derived units. So these things are very important, children. Go through all the things, okay, and you have to write this chapter column, the system of units as well as FPS, CGS, MKS system. Along with that, what is meant by mixture? What are the types of mixtures? That is homogeneous, heterogeneous. These three questions I have given as assignment. One is what is meant by mixture, followed by homogeneous mixture, heterogeneous question, first one. Second one is what is meant by CGS system, FPS system, MKS system. You should abbreviate all this one. Third one is the fundamental units. Okay, that is physical quantity, units as well as symbol. This chapter column. These three questions you have to complete, children. Complete the assignment. The remaining things we will see in the next session. Thank you, children.